Hi, welcome to Progress Academy. All right, we are given to find dy dx at x equals to minus 1. For this function of y is equals to 1 minus 2x all raised to power 3. Find the value of dy dx at x equals to minus 1. Okay, solution. We know that we are given that y is equals to 1 minus 2x all raised to power 3. All right, you see what I have inside the bracket 1 minus 2x. We are going to substitute it with letter. Let's substitute it with letter u. So let's say that let u be 1 minus 2x. U is what we have inside the bracket. Okay, so such that I want to differentiate this. I choose this to be u because it can be differentiated easily. If I differentiate this u with respect to the letter x we have here, so that is what we call du dx. It will be, let's differentiate a constant, you have 0. Now when we differentiate this, the power here is 1. So it's going to be 1 times minus 2 will be minus 2. If you differentiate minus 2x, it's like you have minus 2x. The power of x here is 1. 1 times minus 2 is minus 2. You write x. Subtract 1 from the power, 1 minus 1. So it will give us minus 2x raised to power. 1 minus 1 is 0. Such that you have minus 2 times 1. Because x raised to power 0 is 1. When you multiply, you have minus 2. That is how we got minus 2 here. Okay. But I made a statement initially. I said let's substitute. Let's say that 1 minus 2x is u. It will imply to give us that y will now be, we call this u. So this will be u raised to power 3. I'm having a function now in y to be differentiated with respect to u. So I'll run again, dy du. Okay, I'm differentiating y with respect to u. It will now be 3 with times the coefficient of u here, which is 1. We have 3u raised to power 3 minus 1, which is 2. Okay, if you observe the question we are given, y is equals to 1 minus 2x all raised to power 3. It's a chain rule. We call it function of function. Okay, and there is a formula we use to evaluate it. We normally say if we want to find the dy over dx of a chain rule of a function of function, we say that dy dx is equals to du dx multiply, that is times dy du. Okay, we have not altered the left hand side. We have not altered dy over dx because if we cancel out du we still have dy over dx. Okay, you see that the left hand side still equals what we have at the right hand side. All right, so we are going to apply what we obtained from du dx, which is minus 2. We substitute it here, and what we obtained as dy du, we substitute it here. This will imply to give us that dy dx will be equals to, what is du ds? Minus 2 multiply, what is dy du? 3u squared. It's multiplying 3u squared. So let's multiply it. We have that dy dx will now be, if you multiply minus 2 by 3u squared, you are going to have minus 6u squared. Okay, finally what we are now going to do is to bring back this same value which we substituted for u initially in this function. So therefore dy dx will be equals to minus 6 into, what is our u? Our u is 1 minus 2x. So I substitute it, 1 minus 2x all raised to power 2. So this is dy dx. But they gave us at a point where x is what? Minus 1. So we now say at x equal to minus 1, we are going to substitute minus 1 into the value of for x in this expression. So dy dx will now be minus 6 into 1 minus 2, that's 1 minus 2, and x is minus 1 now. I open bracket, minus 1 all squared. Okay, so let's break it down. This will give us minus 6 into 1 minus 2 times minus 1 is plus 2. So we have plus 2 all raised to power 2. This will give us that dy dx is equals to minus 6 into 1 plus 2 is 3. 3 raised to power 2. Now, what is 3 raised to power 2? 9. So dy dx will now be minus 6 times 3 raised to power 2, 9. Finally, the value of dy dx at x equals to minus 1 becomes minus 6 times 9. And that will give us minus 54. Bye.